We're now going to have a look at solving quadratic equations simultaneously. We'll solve our first example graphically. We have a linear equation and a quadratic equation. So we'll start with the linear equation and we'll locate the y-intercept of 2. Then we'll use the gradient of 3 to locate another point. So we'll go up 3 and out 1. Repeating that gradient of 3 there, we can locate another point. And we can even go downwards from the y-intercept and locate more points. Joining all those points up in a straight line will give us the linear graph. Now by going out towards the end of the graph there, we'll get a nice accurate graph rather than just using those first 2 points. Now we'll work on the quadratic equation. We'll factorize it and we can find our zeros there. By putting x equals 0 or x equals minus 4, we'll get y equal to 0. That will locate the x-intercepts. So they are 0 and minus 4. We can then take a point in the middle there so that we can find our turning point. So putting x equals minus 2 into that equation there, we'll get y equals minus 4. So we can plot that point as well. Now we can locate another point by putting x equals 1 into our equation. So that'll give us y equals 5. So there's another point at 1, 5. And we can find another point that's symmetrically opposite over on the left-hand side there. Now joining all those points up in a smooth parabola will reveal our intersection. And we read those off as minus 2 minus 4 and 1, 5. We can solve these same equations algebraically using substitution. So we will get x squared plus 4x equals 3x plus 2, and then we can subtract 3x plus 2 from both sides to put all the x on one side. We can factorize that now to find our solutions. So we're really looking for the factors of minus 2 that add up to 1. So that'll give us an x times minus 1 is minus x, plus 2x will give us a 1x. And the 2 times minus 1 is minus 2. So our solutions there are x equals minus 2 or x equals 1. We can substitute those now into either of the two equations. The linear one is easier to work with. So we'll use that one. We've put x equals minus 2 in that first equation and x equals 1 in the second equation. And evaluating those, we'll get y is minus 4 or 5. So our solutions once again are minus 2 with minus 4 and 1 with 5. In this example, we have two quadratic equations that we solve simultaneously. And once again, we can solve these graphically. But our preferred method is the algebraic method using substitution. We can equate those two equations now and we'll get this equation just in x. Putting everything over on the left hand side, we'll get x squared minus 1 equals 0, and that gives us a solution of x is plus or minus 1. We now need to find y, and we can substitute for x in either of the two equations. I've chosen the second one because it looks a little bit easier. So there are our two values of y simply by substituting for x. That's x equals 1 in this first equation, x equals minus 1 in the second equation. Evaluating those, we'll get y equals 6 or 0, leading to our solutions of 1, 6 and minus 1, 0. So we've seen how we can solve simultaneous quadratic equations graphically and algebraically using substitution.